Hello, and welcome to Pre-Calculus Lesson 15. Today we are going to move into the world of two-column proofs. Now, this is an exciting lesson, but it's quite intense. So I want you to make sure that you understand each step. If you have to rewind, go back, rewatch, because we are taking our proofs to a new level. So let's review what we already know. We know 4 congruency postulates. We know the side. So if 3 sides are the same, and in any 2 triangles, they are congruent, which means they are the same. They have the same measurements, they have the same angles. Likewise, side, angle, side. So if there's 2 sides and the angle in between them, we also know that that's true. There's hypotenuse, leg for right triangles only. And there is angle, side. If we have 2 angles, we know the third angle is the same, so they're similar. If the side is the same, then they are the same or congruent triangles. So what we've done before is you've done basic proof outlines, is what the lesson was called. Basically, I had you draw out both triangles, write down the reasons why they're one of these congruency postulates, and then that was it. Well, now we're actually going to prove each line of that proof. So let's start with a simple one. Right. Oh man, we have no simple ones. Here you go. This is a simple one. So suppose you have this triangle, or these 2 triangles. This one A, B, D, and then this one C, B, D. And we are trying to prove that AD is congruent to CD. So we are proving that this side is congruent to this side, which means I can't use that in my proof. I'm proving that, so I can't use that piece of information, even though eventually we're going to find out that they're the same. Now, they tell us that BD is the angle bisector of angle B, which means that these 2 are the same. Okay? That's given information to us. Likewise, they tell us in the problem that AB is congruent to BC. So I'm given those 2 pieces of information, and now I have to figure out which congruency postulate applies. Since I'm proving one of the sides, the side postulate is out. The hypotenuse leg postulate might work if we knew this was a right angle, but we don't. So, I mean, we really do, but it would take a lot of work to get there, so that one is also out. Finally, the angle, side, I know nothing about these angles, and I don't have that angle right now, so that one is also out. The only one I'm left with is the side, angle, side postulate. Why? Because I have this triangle, the ABD triangle, and I know that this side is the same. I know that the angle is the same. And if I draw my other triangle, I know that side BD is shared between the 2, so that one must also be the same. Remember, we use that little circle to show that. So I have side, the angle in between them, and then another side. Now, how am I going to do the official 2-column proof? Well, your 2-column proof must look like this. You're going to make a T-chart. On the left side, you're going to write the statement, and then you're going to write the reason why that statement is valid. So, my first statement, basically what I want to do is I want to outline that these 2 sides are the same, these 2 angles are the same, and that these 2 sides are the same. Then I can say that the 2 triangles are congruent, and from there I can say that these 2 sides are congruent because congruent parts of congruent triangles are congruent, okay? Or corresponding parts. So if these 2 triangles are the same, then these 2 parts of the triangles must also be the same. So let me walk you through this proof. Again, I've already identified that I'm using the side, angle, side postulate. So I'm going to write SAS off to the side, and then next to those, I'm going to prove each one of those things. So first, let's start with a side. Now, the easiest sides to start with are the ones that they've given you in the problem. So I know that side AB is congruent. And remember, we use equal sign with a little wavy to signify congruent. AB is congruent to BC. Reason? Well, it's given. Always start with your givens. Even if you have no time left on a test and you left this problem until last because they're really long, I understand that. At least write down the givens so you can get a couple of points. The next given is that this angle is the same or congruent to that angle. How do I write an angle? Well, I need 3 points to write an angle. So I'm going to write angle ABD. And it's important that you go in the same order. So I'm going on side 2 and then to the shared side. So I'm going to do is congruent to side 2 CBD. The order matters. Why are those congruent? Because it was given in the problem. The final one is probably the easiest one to prove. The last side, BD is congruent to BD. Why? Well, I need to come up with a compelling reason why those two sides are congruent. My compelling reason is that they are the same side. It's the same thing. Now, my last step, or my second to last step, is that now that I've proven the side angle side congruency postulate, I can say that the triangle on the left is congruent to the triangle on the right. Again, keeping track of that order like I did up here. Why is that true? Well, that's my statement. My reason is because of the side angle side postulate. After I've proven that the triangles are congruent, some of these problems, that'll be the whole thing. You'll be done. Some of them will want you to prove an additional piece of information. In this case, they asked us originally to prove that AD is congruent to CD. So my proof should end with AD, whatever they're asking me to prove, really, is congruent to CD. Why do I know that that's true? Well, because corresponding parts of congruent triangles are congruent. And so you'll write CPCTC. And that is how you do a 2-column proof. Now let's try another one. I'm going to erase all this and we'll start from scratch. This time, it may not be the same congruency postulate. So we have this shape. And we have PQRS. Now, in this, they give us that angle Q is congruent to angle S. And they give us that PQ is parallel to SR. And they're asking us to prove that triangle PQR is congruent to triangle RSP. So my first step, again, just like always, is going to be to draw out the two triangles. So I'm going to draw this one. I'm going to draw this one. And write all the letters, because that's going to become really important later. P, S, R. Okay, now within these triangles, they gave me two pieces of information. That this angle is congruent to that one, and that these two lines are parallel. So I know nothing about the sides except for PR is the same as PR. I'm not surprised. So I know one side only. That gets rid of, if I look at my postulate list over here, I only know one side, so this guy's out, and this guy's out, and this guy's out. So I'm looking for angle, angle, side. Now, what's the other angle? The trick is with parallel lines that usually more angles are congruent. Let's look at this picture and see if this helps. You guys have done problems like this before, where you have a line going through two parallels. What do you know? You know that this angle is the same as this angle, because they're alternate interior angles. So if you apply that to this picture here, where we have two parallel lines and a line going through them, that tells us that this angle down here is the same as this angle up here. Or in my little pictures, that angle is that angle. From all of that information, I can write my two-column proof. Why? Because I've proven an angle, another angle, and a side. So how are we going to do this? Well, we'll jump back over here. And we're going to do our two-column proof with our statement on the left and our reason on the right. Now, since I'm proving angle, angle, side, I need to have an angle, and a side. You must write those out. Now, what's my first angle? Well, I like to start with the one that's given. That one is congruent to this one. Remember, angles require 3 letters, so this is PQR is congruent to RSP. Why? Because it's a given piece of information. Next, I need to find another angle. I said this angle is congruent to that one because they're alternate interior angles, a term that we learned earlier this year. So I'm going to define that angle as QPR, and that's congruent to SRP. Notice that I'm keeping track of the order that I'm using. If I went from angle 2 to angle 1 to angle 2 to R, or the third angle, I need to do the same order over here. 1, 2, and then the unknown. So that's why I did SRP. Why is that? Because they are alternate interior angles. Finally, I know that the side is the same because it's the same. So PR is congruent to RP because it's the same. So now I can say, because I proved angle, angle, side, that triangle, and we're trying to prove PQR, so I'll use their order there, is congruent to RSP. You have to have this as your last statement, whatever you're trying to prove. Why is that true? Because of the angle, angle, side congruency postulate. These are really tricky. I hope that you've already done this part a lot so you understand how to do that. So as we move into the two-column proof, it's a little bit easier. And that, my friends, is problem set 15.